Well, welcome to this online revision session for AQA M2, in which we will be considering the June 2010 question 9 on circular motion with a constant speed. Well, in this particular question we have a mass of 8 kilograms on the end of a string, and the string is elastic, and we're told it has a natural length of 1.2 and a modulus of elasticity of 192 newtons. And the particle is rotating on a horizontal surface so that it moves in a circle with a centre O at a constant speed of 3 meters per second. And we have to find the radius of the circle. So we know that this radius is going to be 1.2 plus an extension x as the particle rotates around. And we know that the force is on this particle, that we have a normal reaction with the surface, and we have its weight, and then we must have a component towards the centre of the circle, which is being created by the tension in that elastic string. So we know two things about that elastic string: that the tension will be equal to lambda x over L, where lambda is the modulus of elasticity, x is the extension, and L is its natural length. We also know that this tension must be sufficient to create the acceleration towards the centre of the circle. So it must also be equal to mv squared over r. And so if we compare these two parts, the only thing we do not know is x. And of course r is written in here, but that is also in terms of x as well, because the radius of the circle is 1.2 plus x. So if we substitute in there, we can then see we will get 192 x, which is the extension, over its natural length, which is 1.2, must equal its mass, which is 8, its speed, which is 3 squared, over the radius, which is going to be 1.2 plus x. Now we can rearrange and solve, hopefully, this set of equations. So firstly, 1.2, will that go into the 192? And the answer to that is yes, it will, and it will go in 16 times if it was 12, but it's 1.2, so that will give you 160x is equal to, and then this side is going to give you 8.8 times the 3, that's 72 over 1.2, so that's 72 over the 1.2 plus x. So if we now take that over to the other side, we're going to get 160x multiplied by the 1.2 plus x equals 72. So if we expand that bracket, we're going to get 160 x squared 160 times the 1.2 takes us back to 192x. And then we can subtract 72 from that to make it equal to 0. But really nice to reduce the size of those figures. Well, it looks to me as though 8 will go into everything there. So 8 into this gives us 20x squared. Plus 8's go into this 24 times, gives 24x. And 8's go into that 9. So that is our quadratic. Chances are it will factorise. If not, you can't see how to do it and you'd end up using the formula, but I think this will factorise because we could have 10x here and 2x here, and then to get the 9 we can use a 3 and a 3, but one's positive and one's negative. So we want positive 24x, so if we put a plus 3 into this bracket, that will give you with the 10x 30x, and then when I put the minus 3 into this bracket, that will take away 6x. So that's equal to 0. And so if that's the case, that gives us two possible values for x. X could be 3 over 10, which is 0.3, or x from this second bracket would have to be a negative 3 over 2, or a negative 1.5 in other words. Okay, well, it's very obvious that this second solution is not appropriate. You can't have a negative value for the extension because of the fact it's an elastic string. So x must equal 0.3. So the radius of the circle must be equal to 1.2 plus 0.3, which is equal to 1.5 meters. Okay, 8 marks for this particular question. Recognising that the particle is moving under mv squared over r would be 1 mark, and recognising that the radius is made up of 2 parts, the 1 plus x, and writing that in here, that would give you a mark for that statement. For then having an expression for the tension, the lambda x over L would give you a method mark there for that one. And then putting that equal to the mv squared over r would give you a method mark. There would be an accuracy mark somewhere in here as well for this. Then for obtaining the quadratic equation would give you an accuracy mark for that. For factorising it or obtaining the solutions to this by suitable means would give you a method mark, and then for finally stating the answer for the radius correctly would be a method mark, sorry, an accuracy mark. So it gives you 1, 2, 3, 4, 5, 6, 7, 8 marks in total. Hopefully you found that answer helpful. For further support for your revision, please go to the Further Maths Support Programme website.